Hello? Do you hear me? We are live. Yes. Okay, so welcome everyone. Thanks for being here. I hope that you are enjoying the event and the conference so far. And I would like to start introducing myself a little bit and the motivation of this workshop. My name is Rosa Castillo. Just to give a bit of a background about my studies, I did computer science. I completed a PhD in computer science, and I worked many years as a software engineer. And just 3 years ago, more or less, started working as a data scientist. And I'm also an ambassador of an organization called Women Tech Makers. And basically, we organize events in which we try to improve the diversity in tech. So we organize as well the International Women's Day every year, and this year the proposal was this workshop, which is a workshop that brings together two different perspectives of building AI products. So the development perspective and the design perspective. As a data scientist, I have been always at the side of development. So for me, it's also very interesting to know the points and the aspects that you need to consider also from the user perspective. So while we are presenting the first slides, I would like to ask you some interaction. I know that some of you have had lunch already, so might be a bit sleepy, but please share in the chat where are you from, and if you are involved somehow in developing AI products, if you have some experience from development, design, or whatever, feel free to say hey, hello from wherever, just to start some conversation. Okay, and the next slide. Let me. Are you okay? Oops, sorry for that. And the next slide is exactly what I have said, that the workshop is divided in two parts. And the first part is where we're going to answer the question how you build AI products, and we are going to build a neural network, a very simple neural network using Colab and TensorFlow. And on the second part, we're going to explore a guidebook that was released in 2019 by Google, and is the collaboration of two different teams in Google, the people developing AI products and the research team regarding users' experience. And it contains many guidelines that you should consider when you are building AI products. And more specifically, we have people from Rome. Ciao. And more specifically, the content. I have some delay, apparently, when going to the next slide. Let me just share this one. Sorry, I don't know why it's not showing it. Okay, now I can do it here directly. More specifically in minutes, it's going to be half an hour. The first part, we will cover some instructions, and we will go together through a first exercise of building a neural network. And then I want you to interact, and I want you to build also a neural networks in the second exercise. Then, as I was announcing in the Slack channel, there will be a short break of 5 minutes before starting the second part. I expect that you join me in a specific room to have. We are going to be few people, so it's perfect for small networking. So you can ask me directly questions or share experience. How far are you enjoying the workshop and so on. And then we will go for the second part, which is going to be a bit shorter. And it will cover the different chapters of this guidebook that I explained before. But because we don't have time to cover everything, we will concentrate in the chapter regarding explainability and trust, and how to show model confidence. And finally, there will be time for Q&A, and I guess that is going to happen on the Slack channel. Cool. So let's start with first thing that you need to consider, and is which is your role in building AI products or in consuming AI products, because we all have a part. And to have a simplification of which are the steps or which is the process that you need to follow when you are building AI, we prepared this slide, and it contains three parts or three phases in development and developing the building AI products. And the first part is where you are collecting data, and data that you're going to use to train a model or build a model, and that data is can be labeled or not. Then in the second part, you use that data to build a solution, a model, and you train it, and then you evaluate the model until you decide, okay, it's finished, it's ready, and then we are showing some predictions, some results. And this is an iterative process, so you might go back to the training part if you receive new data or you want to incorporate changes. And the question is, people building these processes or people participating in these machine learning processes are humans, right? So we are having an impact in each part of this pipeline, AI pipeline. And this impact is on the first part because we humans are choosing the data sources that we're going to use to build our AI products, okay? And that's not a machine deciding, it's not automatically chosen or whatever. Is you or whoever the team deciding, I think, or we think that this is the data that we need for this. And in the second part, we are also choosing the evaluation metrics. So this is important because depending on the metrics that you use, you might consider a model good or bad. And this is human thing. So you are totally affecting the model, the final model that you're going to choose. And finally, on the last part, humans are affected by the predictions of an AI product. So this is a summary of this building AI products process in three phases. Keep in mind this slide because we will come back to this slide during the workshop to see how we are covering each of the different parts. Okay, let's get started. I'm seeing and watching also the comments in YouTube. So people from Copenhagen, at 10 screens. Hello, everyone. Okay, the first thing I want to explain is give a bit of understanding of deep learning. Obviously, this is not a master class of deep learning because it's a complex field and we cannot cover that in not even 2 hours. So I borrowed this slide from the lecture of the Massachusetts Institute of Technology. It's a very interesting course about deep learning, and in the introduction to deep learning, they gave this nice graph about the framework of the learning. So we have artificial intelligence that is trying to mimic the human behavior. Then you have the machine learning, which is when you are using specific algorithms and to learn without being programmed. And then finally, the deep learning is the specific part where you're extracting patterns, okay? And you use neural networks to do that. So how we are going to cover this part is we are going to use a framework called Colab. If you're familiar with Jupyter notebooks, is pretty similar. It allows you to execute code, to introduce text as well, and it contains also a free GPU. And I put here, so there are 3 points here that you need to consider. Is that you need to enable the GPU in the Colab notebook, check that you can execute the running cells and edit them without any issues. And if you face any problems or errors, you can always restart the runtime kernel and start all from the beginning to execute everything. That can happen sometimes, that when you're facing some errors. As I said, we're going to use TensorFlow. We're going to use TensorFlow version 2 to build a neural network. And TensorFlow is a Python library. It has a backend in C++, but is used also as a deep learning framework. You can develop code in Python, in JavaScript, or C++. It was released by Google in 2015, and it has a big community of people contributing and participating. So yeah, today we will see some functions and commands that we can use from this library to build a simple neural network. And having said that, let's jump to the notebook. Let me share with you the link on the chat. I will put it here on the YouTube channel. And if you click there and you go there, it opens this Colab notebook. And as just to refresh the things that I mentioned before, in runtime, you have here where you need to check that is the GPU accelerated selected. And you have text cells, and you have also code cells, which are these ones here where you see a play. And as I mentioned, if you ever try to run something and face some error, you can always go to runtime and say restart runtime. Obviously now we have not started executing anything yet, so that's why it's this disabled, but you will see that enabled later. So first thing that we need to do is I recommend you to make a copy. I don't know if you are logged. You need to be logged if you have a Gmail account. And I would say save a copy in your drive, and that will open a new tab. And while we're doing that, because obviously this is a write protected notebook, so you will not be able to save any changes in this notebook. So if you want to keep your own copy where you can play, explore, change things, so take your own copy, you can renaming. Let's start reviewing, as I said, the first exercise together, which is this MNIST exercise. Then we will have time to cover together, or you will have time to explore the second exercise. And as you see, is a very long tutorial. Obviously, we are not going to cover in 1 hour everything, so feel free to go on with this tutorial at home and keep me if you have questions or whatever, you feel free to reach me. Cool. So as I was saying, the first thing we are going to do is to import the TensorFlow library, to check the version, to check that also that we have a GPU enabled. That should be more or less quick. Okay, so we have the version 2.5, and if you have curiosity about which specific version of the GPU that we have, for those who know a bit more about GPUs, you can always type this command that is set here, NVIDIA SMI. And then when you run it, you will see the type of GPU that we have, which is a Tesla T4. I think this is from 2018. And yeah, so what we are going to do right now is just import the Keras API from the TensorFlow library, and also this graphical matplotlib library. And we are good to come back to the presentation, because this is the first thing we're going to do, just import everything that we need, check that the GPU is running and available, blah, blah. Cool. And coming back to the presentation, let me present again. And let's go to the first part, that is importing the data set. The dataset that we're going to use for this first exercise is called MNIST. It's a very famous dataset in computer vision. Some people say it's considered the hello world. Um, Maybe the Git link, Enrique. I don't have the Git link right now, so if you can go to the link that I provided on the YouTube channel, you can make a copy, and I will look later for the GitHub repository. Okay, so the data set, as I was saying, is this MNIST. It has plenty of handwritten digits, and you have also the labels for each image. And what we are going to do is to build a classifier. So we are going to give an image of a handwritten digit, and the neural network needs to guess which is the number associated with that image. We will use 60,000 images for training the neural network, and 10,000 for evaluating and testing it. The images are in grayscale. We don't have colors here, and the size is 28 by 28 pixels. And the command below is the one that we will use to download the data set. And remember the slide that I mentioned at the beginning, that is important to remember. So where are we now? We are on the very first part, that is, we are choosing the data that we're going to use for our product, for our AI product. And in this case, they are already labeled and they're beautiful. I don't see any link to the notebook. Wait a minute. I will share it again. Please try to click here. And let me know, Christian and Enrique, if you have any issues accessing it. Okay, so as I said, we are in this very first phase of collecting everything and the data. So I go back to my copy of the notebook. Neither me don't note if I missed somehow. So I just shared the link. Let me know if you can access is this link here. Okay, it should be the same one that I shared before. And as I said, the data set that we're going to use is MNIST. So let's download it and just do a quick check of the shape of the images, train images, and we have 60,000 samples. That's fine. 10,000 here, perfect. And we are going to also check the labels of the images that we have, and these are integers between 0 and 9, the numbers that we need to classify. And we need some preprocessing here. Is this the main motivation usually is to accelerate the conversion of the algorithm. Okay, YouTube is hiding the link. So are you all on the Slack channel? I will share it there. Okay, I go to the Slack channel. I'm on track 2, and I will share there. I don't know if there is any issue with YouTube and not allowing me to share the links. That's why. Sorry for that. I didn't know that you were not seeing the links. I pasted it on the Slack channel track 2 of ConfCo. I don't know if you are there. If there is anyone from the organization, I could. Yeah, I posted already. Okay, cool. Okay, so coming back to the notebook, as I was saying, there is some normalization, or we are going to scale the images to. Thanks, they share already the link there, but it's also on Slack. So we're going to scale to accelerate the training, because if the range is slower, it's not too big, the acceleration, the conversion is quicker. And then let's display some images just to have an idea of the type of data that we are dealing with. After running this, you will see the different images, and below the corresponding labels. So this is a 9, this is a 4, this is a 6, and so on. Cool. So let's come back to the presentation, because before starting writing any code about neural networks, let me give you a brief idea of what is a neural network. And again, this is not trying to be a master class of neural networks. That's a very complex matter, but I want to give you some intuition and ideas about behind the neural network. So basically, neural networks have neurons. And the neurons, what they do is a linear combination of different inputs that you put, and it gives some weights to those inputs, and then applied some activation function, and it gives you an output. So this is obviously a simplification. For instance, there is a component called bias that it has not been included in this image, but adapting that to our specific case. So these different x0, x1, x2 are the inputs that you get from the image. So you transform the image in pixels, the pixels of your image. You multiply those pixels by some weights, and then you can ask, okay, which weights should we use? At the beginning, the neuron does not know, so you use a random values, and it tries to learn the right weights for each pixel to get the right answer for this specific image. And the activation functions, okay, is a more complex concept, but basically what you do is a transformation of these outputs after applying the weights. And in this case is saying everything that you had before the activation from this transform into a value that is between 0 and 1, and using this sigma function. And that's all you need to know for now. If we try to explain that in code, it's like putting the image as a list or array of pixels, and then you connect those pixels with these little green balls that you see here, that those are neurons. In this case, we are building a neural network which has 10 neurons. The input shade is 784, which is the multiplication of 28 pixels by 28 pixels. And why we have 10? Because we are trying to predict a number between 0 and 9. So we have 10 possibilities for the input image. And we use softmax activation because it's transforming the scores that you get at the end of the neuron into a probability. So basically, you want to know from these 10 neurons which one has the highest probability for this specific input. And if we try to add another layer, and that's called the hidden layer, which is between the input on the final layer, we can do it. In this case, for instance, is adding a layer with 128 neurons, and the activation function that is usually used in this intermediate or hidden layers is the ReLU activation, which has the shape that you see there, and is giving you deleting the removing negative numbers. And that's all you need to know for the moment. And let's come back to the notebook, because we are going to execute the code. I hope all of you that got a bit delay on accessing the notebook, don't worry. We will explain, you will review all this in the second exercise. So just try to understand what we are doing, and then in the second exercise, you will have to do it yourself, don't worry. So the linear model, it has these very simple lines of codes. We just have, as I explained, this layer with 10 neurons. And what is added also here is this flattened layer, which is transforming the input image, which is a 2D array, which has the 28 by 28 shape, and we want to transform that into a 1D, an array of just one dimension. That's why we need it. We do that, and before explaining the going further with the training, let's just, so as you see, the model is built, is that, but we need to configure now some things before training the model, and let me explain how it works. The thing is that we already we are building the model. We're in this second part of the AI process or AI pipeline, and we need to define which evaluation metrics are we going to use. How are we going to decide if the model is good or not? And the neurons, they learn by using a technique called gradient descent. And this technique, what it does is that, in our case, we are classifying images, right? So you give an input of an image and you predict a number for that image. When you do that for all the samples that you have in the training, you can compute what is called the error, is how many images have you classified correctly, how many did you do wrongly. And then you can say, okay, in the end, I did well a certain amount, I did so many errors, and I did so many good guesses. That is also can be transformed in something called loss. Okay, so it's the loss is a way of also naming errors. And you do that for a specific group of weights, as I explained, that you have used for your neurons, and that corresponds to a specific point in this loss function of the parameters that you choose on the x-axis. So basically, you used a group of weights, and with this group of weights, the neurons or the neural network dig this mistake, this loss error. You want obviously to reduce that error. So what you do is an iterative process in which you modify the weights of the neurons by applying also a learning rate, and you do that in a way so that in every iteration you try new values for the weights, and you compute again the loss, the errors that you did, and you try to improve. And what you want to reach ideally is this valley here in the loss function, where the loss is the minimum value that you can achieve given all the possibilities of values for your parameters. Okay, this is a mathematical complex. I know it can be a bit heavy the first time you hear it, but you just need to keep the idea that it's a way to learn in an iterative way and trying to reach a minimum error for your network. And by using this Adam optimizer, it does nicely the adjustments of the weights in every iteration for you. Beside this, we are going to use to evaluate the loss, this error, something called sparse categorical cross entropy. The idea is what is painted below in the slide, that in an ideal network, neural network, and what you want is to give an input image, and that the output of the neurons is 0 for all the neurons that are wrong numbers, and just 1 for the right number. But that usually that's not the way. We are talking about statistics and mathematics, so your model is not going to be 100% sure about a prediction. So what you get is a distribution of probability. So you have, for instance, that the model thinks that it could be with a 60% of probability number 2, but with a 20% of probability thinks it could be a 3 or a 1, and then it has a 10% of probability that it could be a 0. But I mean, even that could be for humans. If you see these two, there are people that might see it and think, okay, I think it's a, I don't know, 6, 1, 0, whatever. So we compare with cross entropy these two distributions of probability, the desired one and the one that we are getting with our neural network. And then finally, we have something called epochs. And that epoch is the amount, when you complete an epoch, is the way you measure that you have traversed all the samples in your training data set. And you have already updated all the weights. And then when you start a new iteration, you start again with all the samples. So it's recommended not to use too many iterations in the training data set, because if you are trying to minimize the errors that you do for the training data set, it could be that that model does not generalize well when seeing new data. So if you're trying to perfectly match all that you have seen in the training data, that model is not as good as another model that makes more errors, but when facing and when dealing with new data, it deals better than overfitted model. Cool. So no, it's not time for the break. Sorry, but it will come. What we're going to do right now is to finish this exercise 1. Let's execute what I explained before, these preparations of the metrics and the loss that we're going to use and the optimizer for the iterations, and then let's train it. So when we start training, we will see in each epoch the different accuracy that is achieving and the loss. And we should start seeing some improvement in each epoch. I mean, you can increase the number of epochs and see what happens with the accuracy, if it's more or less. And okay, finally, it has reached an accuracy of 93%. And that is with the training data set, okay? With the images in the training data set, this model is able to predict correctly the 93% of the images. And let's evaluate that with the testing data set. Let's see the accuracy that we achieve. Okay, we see here is a 92%. That's fine. I mean, obviously, the new images on the test data set are new for the model. It has not seen them during the training. So this is a kind of a closer taste that you get of how good your model is going to do when put into production and dealing with new images. And ideally, you don't want to have a very far number from this. It should be always a lower number than the one that you get in the training data set. But the problem with overfitting could be that if you are obsessed in achieving a very high accuracy in training, like 95, 97, it could be that when you test it in other new images, the accuracy that you get can be even lower than this, like 90 or 80, 89, 88. So if you see these two numbers too far apart, that's already a sign that probably you are overfitting your model. Cool. So let's make some predictions on the test images and let's have a look how they look. When we use the predict to get the predictions, and we print the first prediction of the first image on the test data set, what we see here is an array of 10 numbers. Okay, this is the exponential nomenclature. I don't know if you're familiar with, but I would like to ask you now, which number is predicting this neural network for the first image on the test set. Which one, according to these numbers, that they are probabilities, remember? And we said that the number with the highest probability is what the model is saying is probably the most probable number. So I ask you now, tell me please on the chat, which is the number that you think this model is predicting. I will give you some seconds. Let's see. Just for those who are not familiar with the exponential, this basically is saying 6 zeros before this, okay? So the bigger this, the lower the number. Okay, no one is trying to guess. 8, said Christian. Okay, think that arrays are starting in 0. In many programming languages, arrays start with position 0. So 0, we have labels from 0 to 9. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So exactly. The number 7 is the one that has the lowest number of zeros before. So what this neural network is saying is, I think the number with the highest probability is 7. We can transform that with this arc mask, and then exactly is saying that it's a 7. So that's the prediction. That is the end of this first exercise. Well done, both of you, Enrique and Christian. And now I want you to try this second exercise, in which we are going to use a different data set. We're going to do the same thing. You need to build a classifier, a neural network classifier. And the only difference is that this fashion MNIST, it contains images of clothes and shoes, and it has also 10 categories. So to make it very similar to what you have done. I'm going to just do this first step, so you see more or less how you are supposed to do the changes. Obviously, feel free. You can always add a code piece after any of this. Insert a code and start here typing what is saying here. This is one strategy. So you create everything new pieces of code, and then add everything here. Or another strategy is that we are going to restart the runtime just to clear everything from the previous, the outputs and the results from the previous exercise. And now what is here suggesting you, which is faster, is to just remove from the previous code the parts that you need to change. So when we were importing the dataset, instead of importing MNIST, we need to import now fashion MNIST. So I copy this, I go to this part without forgetting to import first the libraries, obviously, because now the kernel is totally new. So we need to import, we need to import again everything. You can delete cells by clicking here. And then here, let's import this, because otherwise I'm going to have an error. I'm doing the wrong button, sorry. Cool. So as I was saying, what we need to remove is this MNIST from here and use fashion MNIST. If we do that and we play, it's already done. And then we just check that everything remains the same. We still have 60,000 images for training, 10,000 for testing, and the labels are still numbers between 0 and 9. We can preprocess the data the same. because they are also images. And now let's paint some images of the training. And as you see here, the images are different from before. We have t-shirts and shoes and the labels that correspond to each one. So 0 looks like t-shirts, 9 is like boots, because we have here 5 that are like sandals. Okay, so that was the first part of this exercise that I did already in the instruction. Import the right data set. So now I want you to go on for the rest of the steps. You just need to do 1, 2, 3, exactly 3 changes, and then the exercise is done. You need to remove to create a neural network with contains more layers. You're going to add a hidden layer, and here you are free to try to put more hidden layers to see what happens, or you can also change the number of epochs, as I mentioned before. Instead of 10, doing less or more. So I'm going to give you 10 minutes more or less to do these changes, and let's see who can get the best accuracy for this neural network. If you need any help, I am here. If you are stuck with something that you don't know how to change, but as I said, it's just looking for this piece of code before adding whatever you need to add new, and also changing the fit, adding a special validation for seeing the evolution through the epochs. You also need to include this history equals in this model fitting here. Exactly. It's not here. You should include it. Well, so I give you some minutes to play a bit. I have my own try here. I will share also after these 10 minutes. And I will also review in Slack if there are some questions. Okay. Is all clear? Just give me one thumbs up or something if everything is clear, or if you need that I repeat something. Remember to restart the runtime kernel just to avoid that you are not getting configurations from the previous executions. So at 150, more or less, or even 2 minutes before, I will start showing the answer. Cool. I'm going to get crazy and put 3 hidden layers. That's not what I have tried here, but let's see. And we need to modify the model fit with this validation epochs thing. Okay, hope that you are doing something. Just try to play a bit. I mean, you don't need to become. It's just for you to play a bit and see how it looks like. Oh, cool. I didn't compile the model. We are getting here the validation accuracy. Okay, 3 minutes more for you to try to get, and then I will ask you that you share which is the accuracy on the test dataset that you managed to get. Okay, I think it finished. In this case, I reached an accuracy of 91. I think before we have like 93. So this one is getting a bit lower accuracy, and the validation accuracy you see here is very far from this one. So probably we are a bit adding too much. And in the test, let's try 88. So very close to the validation accuracy. So there is also something you need to pay attention here, and it's the consumption of your memory, RAM memory, and disk memory. And whenever it's green, it's fine. But if you are trying to use very heavy neural networks and things that require a lot of memory, that starts to become yellow. And there is a moment where it is red, that means that you have reached the maximum limit amount of capacity that you have. As you see here, you have a maximum of 12 gigabytes for RAM and 68 gigabytes for the disk allocation. Cool. I think we're giving 1 minute more. That should be enough to create some, to see which number, if you manage to get something better than this. Can you, whoever has already some results, can you start sharing on the comments? 8815. Okay, cool. Who else? Who can improve that number? Did you manage to, as I said, you can play here. You can play and try to increase the number of epochs and see if you get more or better. Just experience a bit. And we can add also this other code here that was shared to paint the evolution of the epochs. I think this is have you seen this? Have you executed the? I will execute it afterwards. Let's see if I get a better validation accuracy with this one. Okay, time more or less to show some result. As you see, you can play. You can add more hidden layers or less. Here, use one hidden layer, 3, as many as you want. You can also change the number of epochs and then see the differences in the accuracy that you are getting. Look, for instance, here I'm improving the training accuracy. Before I reach here a 91, and I here 93. Oh, and I improve also my validation accuracy a little bit. I think I might get a better number right now. Christian, Enrique, did you manage to get some number of accuracy number of testing? Okay, in here you see this paint is painting the evolution of the accuracy and the loss, and it's comparing the evolution through the different epochs. Since in this last try I put 15, and how the accuracy is improving on the training data set as I improve the number of epochs. But on the validation accuracy, is almost remaining around a mean value of 80 something. So that gives me an idea that even if I improve giving more epochs for this model, I will probably reaching here an asymptote of not getting more than 89 or something like that. And with the loss, it's the contrary of accuracy. So the lower loss, the better the model, and the higher loss, the worse the model. So in the case of this validation data set that we used for the training, the validation data set, just to explain that, I forgot that to explain it just very quickly, is part of the training data set. Lovely workshop, Rosa. I need to drop, but surely we'll see. Okay, thanks, Enrique, for joining. The validation is a part of the training data set that you use during these epochs to evaluate in each iteration how well is your model doing in new data that have not been used for training. So it's a kind of a mini test data set that you use in each of the epochs. Okay, I don't know if we have more people sharing the accuracy that they managed. I can share with you my try here when I did it. I just used adding sorry, let me execute. Manage too many sessions. Ah, great. It's saying to me that I cannot have two at the same time. Anyway, I managed also to get a similar 88 something. I did not manage to get a higher accuracy. And when you evaluate it here, I think it's 89. So I improve a little bit from before, just adding 5 more epochs. And I can make a prediction now and then get also the first prediction. And again, I ask again, which is the category that is getting the highest probability now, according to these numbers. Could you guess? Should you try to guess, Christian, Eddie, which is the highest? So the highest is this one. So it's 9 exactly. Eddie managed to improve. You improve, Eddie, your accuracy. Good. Just by adding some epochs more, or did you change a new hidden layer? Just share with us how you improve the test accuracy. I have here the code to see to show the image of this. We cannot use this as before because it's not a number, it's an image. So we need the plotleaf library to check which is the. So it's a 9, okay, but I want to see it. I want to see how it looks like, and I'm taking. Yes, I'm taking this to see how it looks like, and yeah, it's a number 9. So this is the one here, the category 9. And if we go back to this data set here, it's referring to boots or something like that. In fact, I'm thinking it's exactly the same image as this one. So probably that image was kept for the. No, it's a different one. Okay, it's a boot. Okay, so 9 probably is boots category. Cool. So this was the end of this exercise. As you saw, it's just repeating the exercise we did together for the first MNIST dataset, what with a different dataset, and playing a bit with the number of epochs, the hidden layers. There is more here for you to check, but it's following this similar strategy. It's very straightforward to understand all the exercises. Feel free to finish that at home. We are now going to make a short break. My idea is that we go together, since I believe we are a few people. We can jump to a Google Meet room that I prepare here. I'm going to share it with you, and feel free to go to the Google Meet room. And the idea is that you share with me how it's going. Do you have any questions you want to have? It will be just 5 minutes. I'm going to paste here the Google Meet. Or you can also, if you want, take a rest and left go for a drink. If you want to go to the toilet, I don't know, just get away from the computer and come back with new energy. But I will be in the room if you want. So I guess we will start streaming in YouTube for 5 minutes. And if you want to, oh, Christian is trying to get the best accuracy, 89. Still, you didn't get the 89 that I got. Okay, I'm going to wait for you on the Google Meet. Hope to see some of you there on the Google Meet and discuss and do some networking before starting the second part. And if not, please come back around 2 or 1 minute past 2 p.m. and we will finish the second part of the workshop. Okay, see you. Okay, welcome back. We have some short break. Hopefully, we have two participants who decided to do real interaction. I got some feedback also from the watcher, which is good as well. And let's finish. It's just the second part is, I promise, is going to be shorter. It's a bit lighter. The first part was neural networks, training epochs, and blah blah blah. But hope that you enjoyed and you got a first taste of how it feels to build a neural network. And let's go. So just to finish this slide that we presented before, we shared before, we are now in the part that, okay, we build a neural network, we have our results, and we need to present that, we need to show that to our users. And when doing that, that's when we should pay a lot of attention of how to do that in a way that is friendly for humans, right? So the idea behind this second part is to bring concepts and questions that you should answer when you are building AI products. And we are not talking only about development, but from a different user perspective. Um, Imagine that I ask you now, okay, you built a neural network. That's great. Could you explain me what exactly did you do? And then you come and you share with me, yeah, I did this. Okay, that's great. It looks pretty complex, and yeah, it has many neurons, and in the end, you see the colors, the high probabilities, the bigger one, blah blah blah, and that might be cool, but for most of the users or most of the people, they will not understand what you are saying. What is the purpose of this? So we need to move from doing things in this way to doing things in this other way. If you explain in a way, okay, I'm doing an image classifier, so I'm somehow getting some features, and then I'm able to extract to identify a cat or a dog or whatever you are doing. So this is more intuitive, this is more friendly, and this is more thinking about humans trying to understand what you are doing. And AI is already in many aspects of our lives, from recommender systems in the music that you hear, or in the products that you buy in Amazon, or movies that you watch in Netflix. And we have also self-driving cars. And the idea is that we should try to go from um, make the users of AI to feel in control of technology, and not the other way around. So this should be the goal of building AI products. To achieve that goal, that was, as I mentioned, this project that was born. They shared a first guidebook in 2019, and this year they released a second edition of the guidebook. It contains many chapters, and we will not cover all the chapters. We don't have time for that. And we will concentrate on the explainability and trust, which is obviously a very key important thing that you need to achieve. You can go to this website and review yourself. I will share also on the Slack channel many of the links that I'm going to share for you to read it carefully at home and explore or whatever. Um, Let me just go briefly through each of the chapters and explain to you what's the goal behind each of them. It starts with considering the user needs and your definition of success. So before building anything or starting designing any neural network or AI product, you should first question yourself, okay, what what I am trying to bring to the user. What is a human or a person consuming this AI product? What is the benefit that this person is going to get from this? And also you need to have a metric for success. Okay, so it's not just, okay, build the product, it's all down and all fine. No, you need to get an idea how are you going to measure if this product was a successful product or not. And then you have the chapter about data collection and evaluation, and it brings you ideas and guidelines about things you need to consider when you are collecting data. And as we explained, this is a manual thing. Usually, in many use cases, it's still a manual thing. And you might be careful with, I highlighted the word bias, because if the data that you are collecting contains some bias or any other types of things, you might introduce that in your model, and that might impact the results of your AI product. So you need to be careful and evaluate and dedicate enough time to the data, because it's a key important part in the building AI models. Regarding the models that you use for building AI products, you need to be careful with the limitations. And then obviously there are algorithms that are cool, and people want to use them everywhere, but you need to be aware of might be cases where this model is not appropriate, and you should inform the users about that in order for the users not to build wrong expectations, that they are thinking that you are building just a magic model that fixes everything. Regarding explainability and trust, obviously, I think I don't need to say why is that important. If users do not trust your model, then obviously they are not going to use it. And regarding explainability, this is a trending thing right now in machine learning models, because before, at the beginning, um, it was many people were accepting that the machine learning is a kind of a black box, okay? But that's not acceptable anymore. You need to explain why are you doing the things that you're doing, how are you doing that. That is called also the interpretability. And there are already even tools and libraries in Python and other languages to help in explaining and giving an interpretation for your users of how the model is doing the predictions in the way that it's doing and what is affecting. Regarding feedback and controls, I highlighted the word customization. You need to decide how much interactivity you're going to introduce in your AI product, and that can be collecting feedback from the users that maybe you need, for instance, in a recommender system. But it might be cases where the customization maybe is not recommended or is not desirable, because it might introduce too much complexity or it might confuse the users. So in this chapter is interesting, but it gives you a bit of thinking of think twice if you really want to introduce as many controls as many customization, or you really don't need that. And the final chapter is the obvious situation in which you will find errors, because there's not perfect models. It's based in statistics and probabilities, so you might have errors with your model. So what are you going to do? How are you going to overcome these errors in a way that you don't lose the trust of your users, right? So that's the gracefully thing. Okay, so let's jump directly onto the explainability trust after this brief journey of all the chapters. And regarding explainability and trust, we are going to cover two things and that you need to answer. And one is how much trust should your users have in your AI system or in your model. And the other that we're going to cover, the question is how you should show the confidence that your model have when doing predictions, right? Um, Regarding spectrum, or regarding trust, there is something called the trust spectrum. We can define that as the all possibilities that you can have in your users, from users that do not trust at all your product, and users who trust too much your product. So these two extremes of the spectrum are not things that you want. Obviously, the people that don't trust your model, because they are not going to use it if they don't trust it. But if you have users that they trust too much, it could be dangerous, because they are assuming things, and expecting the model to do things that the model is not capable of doing, or that the model might be doing wrongly. So you need a calibrated trust. You need to educate your users in a way that they accept the things that the system can do, and they know exactly which things the system are good in doing, but they also know how to question the system when it's not behaving correctly, or they know the limitations, and they know that they need to use their own human intelligence to instead of trusting the model. Okay. And the question is how we manage to get calibrated trust in our users. There are two key things that we should consider. One is the system data that you are using in your model, and the other is which is the user knowledge of your system, or your AI system, about your AI system. For the first one, I would like to share come back to the idea regarding bias. Remember that we say it's very important that you evaluate the data that you are using for your models. And I would like to share with you the real situation that happened in 2018, when some companies were releasing some facial recognition algorithms, big tech companies, and they published, okay, they released the product of identifying the face, and then it was discovered by some people that the product was not working well in some specific cases. And if you have a darker skin, or you were of a different gender, then the model was not getting the accuracy that has been published and acknowledged. And that was because when they were using the data to train the model, obviously they did not pay attention to use a diverse data set. So they tested, or they trained the model with just mainly white male images, and then they decided that it was good enough, and they published and they released it, and that had a huge impact in the trust of the users. And I'm also sharing with you the name of one of the persons who first raised the hand. Was Joy Bolamwini, and she published a paper, and she has also a TED Talk and YouTube. If you want to hear it, is pretty amazing. And I believe they have corrected that already. But you see that even big tech companies are doing mistakes for not following these key things when building AI products. And regarding the user knowledge, obviously, the more knowledge that your user has about the domain, or the things that you're trying to do with your AI products, the more questions that is going to do. And when you have a user that does not have enough knowledge about, I don't know, or technology, or recommenders, or whatever things that you want to build, this person obviously is going to over trust more your product. So the solution for that is to educate more your users and give them trainings or explain very well in a simple way how the model works, so that they manage to get and get a bit more understanding of your AI product. And I prepare now a couple of questions. I want you to answer that on the YouTube channel. After all these topics that we have shared and that we have said, which is important, sharing with your users, which information to build trust and so on. My question is, if you have an app that is giving you a route recommendation for you to walk or to run, in this case, it's probably a fit sport training app, whatever. Which one do you think it could be the best design for your routine app or whatever, regarding trust and everything that we have said? Just I give you a couple of, a minute to think about it, and I will pay attention to the comments. Just, you need to say A or B and why. A? Okay, Christian. Someone else wants to try and think? Okay, Christian, if you think it's A, you need to tell me why. What is the difference between A and B? In A, in fact, is saying a limitation of the model. It's like saying, I did not use street-light data in building the recommendation. And in the second, is saying nothing. So yeah, I mean, just to... Yeah, in the B1, Christian is saying it's open-ended. Yeah, in the B1, it's like saying, be careful, but it does not specify why. So it's like saying, I recommended, I computed this route, then you go and you go on your own. And in the first one, in fact, is showing a weakness point of your model, which some engineers and some people might, or I don't know, marketing people might say, no, you don't want to show a weakness. More like a decision support than a decision maker. Yeah, the thing is that you need to be prepared to share also the weaknesses of your model. It's a threat. Yeah, it's a kind of, when it's saying be careful, if the user reads that, it's going to say, hey, why? I should be careful. It's like kind of like scary. Yeah, I agree with that. So yeah, you both right. The first one is the right one, and it's because it's showing a limitation of your model. It's like saying we did not include street light data in our training when we compute the model prediction. And so it might be that in some parts of this path is very dark, and obviously if it's 6 p.m. in some places of the world, it can be dark enough to pay attention, right? So with the first design, the user knows when to trust and not to trust the model. So in 6 p.m., the model is saying to me that it might be that the path includes parts that are very dark. So it's up to me, as you were saying, Sheriff, it's my decision to follow that recommendation or not. But then it's not fair to just hide that, and then the user goes to the path and find that it's everything dark, and then obviously the user is going to blame and is going to say, hey, why you did not tell that to me? I was expecting you to tell me that. So you're creating wrong expectations. Better to say, no, do not build those expectations because the model does not have that data. And I have another one. This one is a bit trickier. You need to also watch your back. Yeah. Shouldn't you then say why you need to be careful? Yeah. I agree. I would agree with you. Watch out for potholes in the road. Yeah, you don't know what is be careful. Be careful about what? Okay, I have another exercise for you. This second exercise, you need to decide also which is the best design. This is a trickier example. I need to give you a bit of context here. So imagine that is a user that wants to go from one location to the airport. Okay? You want to go to the airport to catch a flight. And then you're getting a prediction of driving time. The app is computing based on some AI product, whatever training, regression model, whatever think. I believe it's going to take you 42 minutes according to the fastest route. And it's saying this is updated, this information every hour. And in the second case in B, is saying this is the fastest route according to the usual traffic. Which one do you think, according to what we said about trust and building right or wrong expectations on the user? This user wants to catch a flight in the airport. So which is the best design, A or B? Let me know. I will give you a minute to think about it. I could go with A. It is kind of specific. Okay. Someone else wants to guess? A or B? So this is trickier because both are giving information about how the prediction was done. But to this specific use case that I'm going to the airport, which specific information, yeah, uses the word usual, which in my word can be interpreted wide. Yeah, I could say the B one is saying the usual traffic. It means in a normal day when there are no issues, no accidents, traffic jams, congestions, or whatever. You're going to take. It's going to take 42 minutes. Let's say since the ride is 42 minutes, update is every could be catastrophic exactly when catching a flight. B is honest about being based on historical data, usual and daily averages, basically. Yeah, Smerden, or I don't know if I'm pronouncing well the name, Smedengard Pedersen. I'm very bad pronouncing. Sorry for that, but I get your point. That's why I said it's tricky. This one, the B one is saying that it's computing the route based on the usual traffic, but it's not saying any information about how often are you updating that information. So, okay, you are telling me that based on historical data of previous, maybe Mondays, if it was a Mondays or Sundays, in a usual normal Monday, you would take 42 minutes to go to the airport. Doesn't talk to everyone as soon as we're talking to profile ID using exactly. That's customization, what you are saying. That also can be also considered if it's customized or not. I agree when you say the usual traffic is considered historical data in the database that you have collected of this route of people doing that with the car and taking 42 minutes, but it's not giving me information of how often is that updated. And as I think it was Christian or whoever, sorry, Smeden was pointing out, if I risk to miss a flight, I want to know how often are you going to update that estimation. Because imagine that in half an hour, after 20 minutes driving, there is an accident on the road, on the highway, and that's not collected in your computation, and you don't update that because you are updating every hour. So the app is going to still showing me 42 minutes, but it's wrong because it has happened an accident. But since you did not include updated most recent data in your application, I'm not going to get that update. The app is still going to say to me 24 or 42 minutes according to normal. But in the first one is saying, be careful. It's like the be careful in the previous example. I am going to update this information every hour. So it's up to you if you decide to follow this estimation. And if it happens in less than 1 hour, an accident, and it's not the time that I'm doing the refresh of my data, you are not going to get that information in this app. So I would say the right design in this case, as I explained, going to the airport, it could be it could be tell the user that there is a limitation of your model, that you are going to refresh the data every hour. So if something happened in less than an hour, you might not see that in the app, and the estimation is going to be wrong. It was clear for you? You still have questions or things that was not clear about this specific one? I know it was tricky. And in fact, because I think this is from Google Maps, but you don't need to imagine that it's Google Maps. I just said an app, a generic app. I think Google Maps includes recent data, but still I don't know which is the refresh frequency of that data. So it's still tricky to get how often that data is being refreshed. Good. Thank you for participating and getting some discussion on this. Let's move to the next slide. We covered already the trust, and we discussed a bit how well, which information, which weaknesses you need to show to build the trust, and so on. And now it's time to choose and see patterns of ways of displaying the confidence of your model. And before even doing that, you need to ask yourself, do I really need to display confidence of my model? That looks like a trivial question. It might be like, why not? There are cases where maybe showing confidence might not be the best thing to do. If it's going to introduce more doubts, or the user is not able to interpret or to understand how you're showing the confidence. So you need to really be sure that you're bringing value when showing the confidence of the model, okay? And the best way to find the best pattern, the best way of showing confidence, is to study your target users, and maybe you go for a way of showing the confidence, and it is not working, and you need to change it for another one that the users like more. So that's why it's called a test and iterate. So there is not a ground truth about what is going to work for your AI product. So you need to choose one that you think is going to give you more success, and then if it's not working, just change it, and that's it. There are several ways that you can show the confidence level of your model, and we are going to explain each of them. The categorical one, the MNIST, the numeric, and the data visualization. These are the four that we are covering in this guidebook. And the categorical one is recommended when, or it works well when you are quite confident. So with your prediction, and you put that prediction or the best match that you think in a highlighted position, or in a best placed in the app, or in the whatever graphical interface that you are using, if there is a graphical interface. In the case of a text predictor, like the one in your mobile, the word that is considered the most probable is placed at the center and then the other best good guesses are in a side position. So the user, the first thing that usually sees, the one thing that is in the center of the eyesight. That's called the categorical way of showing confidence. Then we have the M-best. The M-best is usually recommended when you are not very sure, or you are not very confident of the predictions of your model. So what you do is just you share a list, and probably the positions on the list is obviously sorted according to some confidence ranking or score. And that's for instance, the solution that they used in Google Translator. So where they are not sure that what is the best translation, they let the users choose which is the best one, the one that they like the most. Okay, so as I said, this one is when you are not 100% sure about the predictions of what is going to be the best match of the prediction. And then we have the numeric one, and with this one I go back to the initial idea that I said that be careful when showing confidence if that is going to confuse more the users or not. When showing numbers, and in this case probabilities, you are assuming that the users have statistics understanding or knowledge, or they know how to interpret these numbers, right? Maybe not many people, not all the people know that. And even if they know that, then there is someone, there are people that understand probabilities. These numbers, they lack sometimes the context. It is not an absolute measure that, for instance, saying, okay, a 92% of accuracy might be great in some cases, might be very poor in other ones. If the user does not have a comparison to say, is 94 is just comparing to achieving 100% probability. It's just that sometimes it's not as simple as that. Just to give you an example, a real example, the text predictors that you have on your mobile phones, they use an algorithm, and the accuracy that they usually have is very low. So if I say to you that the text predictor algorithm of your mobile has an accuracy of 40%, you might say, oh, that's very bad. But in fact, it might be really good, because the state-of-the-art algorithms in predicting text, they are mainly achieving less than 40% accuracy. So if I show you 40%, that might confuse the user, might think that is a bad app, but in fact it's a good app. But you don't have the context of what is the normal accuracy for this kind of algorithms or products. So I know that was the accuracy some years ago. I don't know if they improve it now, maybe with the pre-trained NLP models or so ever. But when I was researching a bit that area, I remember that I achieved with my model 20 something, and I thought it was a very poor accuracy. But when I checked that the state-of-the-art models were achieving 32, 35, I thought, oh, well, it's not so bad. And the final display confidence representation we have here is data visualization, and this one is very so specific in a way that is showing a lot of details. You can even show graphs and numbers, and that's recommended when you have users with high domain knowledge, or they are experts. Imagine doctors or people with a lot of knowledge of the things that the models are predicting. So they want to know a lot of details in this prediction, and not just a number or a percentage. So that's why this confidence level option is just recommended in some specific cases, like for instance medical apps or things very specific for some trained people. Now we are going to do an exercise That's going to be our final exercise. And imagine that you have a client or that is requesting you to build an image classifier. Well, you did that in the first part, okay? But in this case, imagine that it was a dog identifier, so the breed of a dog that you want to identify with your model. Which confidence pattern from all the ones that you have seen so far do you think would be the most useful for the users? And I'm talking about generic users, okay? Not thinking about experts in dogs, breeds, or whatsoever. So again, I give you some minutes to think about it. Choose one and tell me why. Do you think it should be categorical, or it should be a numeric percentage, or it should be a list, an M best, or it should be some data visualization, I don't know, of breeds and dogs in bars and so on. Let me know. Try to guess. Okay, Christian is saying M best. This can be a mix. Someone else before I reveal? Okay, time. Categorical, inclusive, more chances. Okay, Eddie, you need to justify. Categorical means you need to be really sure that your model is guessing right the breed of a dog. So you need to be quite, it needs to be a model with a high accuracy of predicting breeds. But I agree. Yeah, that's for sure. The thing here was between categorical and MBEST. That was clear. But that was a question between categorical and MBEST. Which one do you think? And the solution is MBEST. Why? Because it's a bit, it is like Christian was saying, with the breed, sometimes when dogs are mixed or whatever, it might be tricky. It might be difficult that you build a model with, I don't know, 90 whatever accuracy of the breed. So if you find or you build a model that doesn't have a high accuracy, you don't have a high confidence on the predictions, don't go for the categorical, because the categorical is like showing in the middle is this one, and it's like you're pretty sure that that's the solution. So what they follow in Google Lens, that I think this is what they are doing, identifying images, they go for the M best, like saying, I believe the closest breeds for this dog are this, and you are the one choosing which is the right. You can go with your swipe with your finger and choose the right one. So yeah, it was the M best. Cool. So we managed to the end, and you're still alive. I prepared some resources for you to explore more. I will share that on the Slack channel for you to copy that maybe on some text file or whatever. The first one is this second edition that they prepared this year to give you an idea of these different exercises with the pair guidebook. It is a collab where you need to also, I think there are some exercises as questions that you need to answer and so on. The second one is a tutorial on TensorFlow, so it gives you more idea of the things that you can achieve and get using that library. And the last one is a more specific on machine learning and using Keras, and it's a GitHub repository that you can also follow and follow the exercises. That's it's all from my part. There's a final thing I would like to request you to fill a short survey just to have a feedback about things that you like about the workshop, things that you would like to improve or whatever. Just feel free. I'm going to also share the link in the Slack channel for the survey. And this is my email. Feel free to reach me. I think I shared also at the beginning my Twitter handle. Feel free. I will also type it here right now if you want. Let's see if YouTube is allowing me to type Twitter handles. I'm not sure if it's going to be also deleted. Yeah, I'm available for the next 10 minutes on the Slack channels to discuss any questions, things, and that you would like to share. Yeah, go on and become AI expert. Thanks.